The previous two videos were the start of our path into inferential statistics, trying to make some conclusions about the relationships behind the data. This video moves into the most important definitions of inferential statistics, hypothesis testing. We want to understand the basic ideas and the definitions in this video. And I'll present this through an example. A certain study had this research question. Do male bank managers discriminate against female employees in promotion decisions? What is the population? Recall the word population for a research question is all of the possible cases. Here, the question is about promotion decisions made by male bank managers. Therefore, the population is precisely that, all promotion decisions made by all male bank managers. You could argue that the population be limited, maybe to only banks in Canada. That would be reasonable, but in any case, it is a set of all of these decisions. That's the population. What is the sample? Recall that the sample is the actual data, the portion of the population that we know something about. In this study, the sample was 48 specific promotion decisions that the researchers were aware of. The dataset then has 48 cases. Each case has two variables, gender and decision. Both are nominal categorical with two categories, gender split between men and women, and decision split between promoted and not promoted. The gender here refers to the gender of the applicant. Remember, the study is only about male managers, so that part is fixed. Here is the contingency table for these two variables. Of the 48 cases, exactly half were men and half were women under consideration for promotion. You can see from the table how many were actually promoted. And I can read this as proportions. 87.5% of the men were promoted, and 58.3% of the women were promoted. And the difference between these two proportions is 0.292, or 29.2%. Let's make sense of this 0.292 proportional difference. Again, the population is all instances of promotion decisions made by a male bank manager. I can use P sub m for this value in the entire population of how many men were promoted as a proportion. Proportion is important here for comparison, since the number of promotion applicants in the entire population is not guaranteed to be perfectly split between men and women. Again, I can use P sub f for the proportion of the women who were promoted in this situation. And as I did in the last slide, I can look at the difference. This is a measure of how much men were promoted more often than women. This is a parameter. Again, recall the definition. A parameter is a fact about the entire population. Parameters are unknown. The study did not, in fact, look at every possible promotion decision for every possible male bank manager everywhere. It only looked at 48 decisions, a tiny fraction of the whole. Statistics is about trying to say something about the unknown parameter using the partial information of the study. So we have a sample that I've already described. What I calculated on the previous slide is the sample statistic. It is something which is true about the sample. In this sample, there was a 29.2% difference in how often men and women were promoted. The question, as always, is this. Is the sample statistic representative of the parameter? Does this study capture something that is likely to be true about the whole population? Hypothesis testing is how this question is formally set up. The setup is a bit strange, but there are good reasons for it. Hypothesis testing always starts with a null hypothesis. This is a default situation, and it always says that there is no relationship between the data. Nothing is really going on here. This is always the default, since the vast majority of variables in the world are not directly connected. The Canada goose population in Ontario has nothing to do with the price of lager in restaurants in Rome. In this case, the null hypothesis says there is no difference in the whole population between the promotion rates for men or women under the decision of a male bank manager. This can be stated mathematically. PM and PF were the promotion proportions, so the null hypothesis says that the difference of these two is 0. Hypothesis testing always starts with a null hypothesis, some version of saying that nothing is going on with this data. The purpose of a research study is to reject the null hypothesis, to say that, yeah, there is something going on here. and this gets stated as the alternative hypothesis. Here it says that the variables gender and decision in this data set are not independent. They actually point to a difference in the is actually larger than 0. Men do get promoted at a higher rate than women, at least under male managers. This is the hypothesis. You could argue that the alternative hypothesis should be even more broad here. It could just be a strict negation of the null hypothesis. So maybe just the parameter is non-zero. Maybe in the whole population, women actually have a higher promotion rate. This version of the alternative hypothesis would allow for that reality as well. This is the setup of hypothesis testing. Understand what the population is, what the parameter is, and how the sample statistic is a limited measure of the parameter in the sample. Make a null hypothesis, some version of saying that in the whole population there is no relationship to measure in the data. Then make an alternative hypothesis, saying there actually is a relationship. Then figure out if the sample statistic actually supports the alternative hypothesis. That's it for this video, which just defined the terms and set the stage. And the next videos will start answering the question of how to do this.